The goal of this class is to learn about how does all of the radiography equipment work. So eventually, at the end of this course, we'll be talking about CR equipment, DR equipment, fluoroscopy equipment. We'll even talk about the X-ray tube and how we produce an image. But first, we need to talk about electricity. And then from electricity, we're going to learn about circuits. And then from circuits, we'll learn about the X-ray tube and how we actually produce radiation. To understand electricity, we need to understand the smallest basic unit of electricity, which is an electron inside of an atom. An atom is composed of two parts, the nucleus, which has the proton and neutron, and the electron shell, which has the electrons. Inside the nucleus again are the protons and neutrons. The protons are positively charged, and the neutrons have no charge. The electron in the electron shells is the smallest unit of electric charge, and it is negatively charged. While an electron is one unit of negative electrical charge, a proton is one unit of positive electrical charge. What I find to be really interesting is that one electron and one proton have the same magnitude, but they're in opposite signs. Atoms can have a net positive or net negative charge. For example, if an atom has more protons than electrons, then that atom will be overall positively charged. However, if the atom has more electrons than protons, it'll have an overall negative charge. Atoms do not always contain the same number of electrons and protons, although this state is common. When an atom has an equal number of electrons and protons, it has an equal number of negative electric charges, the electrons, and positive electric charges, the protons. The total electric charge of the atom is therefore zero, and the atom is said to be neutral. In contrast, when an atom loses or gains electrons, or the rarer case of losing or gaining a proton, which requires a nuclear reaction, the total charges add up to something other than zero. The atom is then said to be electrically charged or ionized. When there are more protons than electrons, it is a positive ion called a cation. When there are more electrons than protons, it is a negative ion called an anion. The process of an atom losing or gaining an electron, or again in the rare circumstances it's a proton, is called ionization. When we talk about an ion pair, we're talking about the electron or proton that left the atom and then the atom that was left behind. So if ionization is the process of removing an electron or proton from an atom, what is radiation? Simply, radiation is just energy, be it waves or particles, that travel through space. And it can come in many different forms. For example, acoustic radiation is what you're hearing now. You're hearing my voice leave speakers and travel into your ear. That traveling is a form of acoustic radiation. We use acoustic radiation in radiology and ultrasound. The other main form of radiation we use in radiography is X-rays that fall under the electromagnetic spectrum. So let's put the two together. What is ionizing radiation? Ionizing radiation is energy that's strong enough to remove an electron or a proton. In this most basic example, we have radiation that's coming in so strong that it's causing that electron in the electron shell to be ejected out of the atom. So we would call this whole process ionizing radiation. And that's what we deal with whenever we shoot X-rays. When electrons move from one object to another, we call this electrification. And electrification can be created by one of three ways: friction, contact conduction, or induction. Friction is when you rub two different materials together, which causes electrification. Since the two objects are made of different materials, their atoms will hold onto their electrons with different strengths. As they pass over each other, the electrons with weaker bonds are ripped off the material and collect on the other material. Contact or conduction is the physical contact of a charged object to a neutral object. Suppose that a negatively charged aluminum rod is touched to a neutral metal sphere. The neutral metal sphere becomes charged as the result of being contacted by the charged aluminum rod. With induction, you can actually charge an object without physically touching it. This process is going to become very important to us in a couple chapters when we talk about induction motors. An induction motor can turn with no physical contact. We just learned that electrification is the movement of electrons between two objects. However, with electrostatics, we're studying electrical charges at rest. An electrically charged object generates an electric field. An electric field points outward if the object is positively charged, and the electric field points inward if it's negatively charged. There are four laws of electrostatics that you need to be familiar with, and we'll go over each of these four laws in detail now. The first law of electrostatics is that unlike charges attract and like charges repel. The second law of electrostatics is that electrical charges are concentrated on the sharpest curvature. For example, on a taser gun, the very tip of the point of the taser gun will have the highest concentration of electrical charges. The third law of electrostatics states that electrical charges are distributed evenly throughout or on an object, unless there is a curve to the object and the electrons will concentrate on the tip of that curve. The fourth and final law of electrostatics is that electrostatic force is the attraction between charges. We can actually measure that force in coulombs. Coulomb also has a law in regards to electrostatic force, and basically it says that electrostatic force is strong when things are close, but decrease rapidly when separated. This is inversely proportional to the square of the distance. And what does that mean? That means that when the distance between two objects is halved, meaning they get closer together, that means the force between them will quadruple. Want to know a mind-blowing fact? It takes 6.3 quintillion electrons to make 1 coulomb. Throughout the semester, you'll hear me refer to something as ground, grounded, or grounding. And in electrical terms, a ground is any object that accepts electrons. For example, the Earth. The Earth is a ground.